Okay, it says a data set includes data from students' evaluation, the summary statistics, the sample size is 84, the sample mean, X bar, is 4.18, the standard deviation is 0.57, and our significance is 0.10. To test the claim that the proportion of student course evaluation has a mean, so the population mean is 4.25. All right, so we want to test the claim that the population of student evaluations have a mean equal to this. So there's nothing saying that it's less than or that it's greater than. So we're just going to test to see if there is a difference. Your null hypothesis is always, always, always equal. So I know it can't be that one. If I'm looking for a difference and I'm not looking for a less than or a greater than, then I'm looking for a not equal. All right, so that would be my hypothesis. Well done. And now determine the test statistic. Well, the test statistic, and this is going to be a T because we do not know the population standard deviation. How you find the test statistic is, I'm going to let Excel do this for me, is equal. The numerator is my sample mean minus my population mean. So I just click on those values so I could reuse the spreadsheet. Then divided by my standard deviation over the square root of my sample size. So I'm going to put that in parentheses. The standard deviation divided by the square root of the sample size. I close my square root and then I close my denominator. I hit enter and it wants me to round to 2 decimal places, and I'm so lazy. Let's let Excel, oh, I hit the wrong button. Let's let Excel round it for me to 2 decimal places. So that's negative 1.13. Well done. Now it wants the p-value. So the p-value is determined by this value right here. All right, so my p-value, the only problem with, what's this thing called, Excel, is Excel doesn't like a negative on your t statistic. I know this is a two-tailed test, so now it wants, where it says X, it wants that test statistic. So what I do, again, and I reference cells. I could just type 1.13, right? But I use ABS, which says the absolute value of that number. In other words, just make it positive. And then comma, my degrees of freedom, which is my sample size minus 1. So this is a t distribution, a two-tail. Okay, you saw that it had a right tail in the formula as well. I absolute value, so I get 1.13, and then I do my degrees of freedom, which is n minus 1, and this wants in 3 decimal places, so 3 decimal places would be 0.264. Good job. And now it says, tell me what to do. So in this case, what I'm looking at is my conclusion is found by looking at my p-value and comparing it to my significance. If the p-value is greater than the significance, so in other words, that's a high probability that I really can't see any reason to reject the null because my p-value is high, which says the probability I would expect to get a sample with a sample mean of 4.18 based on what they tell me is pretty, I mean, it's not high, but it's higher than my significance. So in other words, there's not any significance. It's not sufficient to say that their student course evaluation is not. So this you're basing off of the alternative hypothesis. All right. Let me show you also, you can do this in StatCrunch. I mean, some of y'all are kind of liking StatCrunch a little bit better. I did a video already with StatCrunch, but it gives you actual data. So here, when I go to StatCrunch, I need to actually tell it that I have summary statistics. So stat, I already know this is a T. We said Y, we don't know the population standard deviation. I have only summary data. My sample mean, so my sample mean right there, the 4.18. My sample standard deviation, the 0.57. My sample size, 84. This is a mu mean, population mean equals 4.25. And be sure you select the right thing here. Okay, it is not equal for this one. And I compute, and you will see I get the same values, the negative 1.13, the 0.264. Okay, so whichever way you like best, but I show the Excel way, that way you actually know how they're getting these values.